Alright, so I'm hoping I can make this video short. This next section gets into looking at word problems and how we would use this trigonometry, these trig functions that we've been learning in real life. So, sorry, my voice sounds weird. This is called angle of elevation and depression. So, we have what we call an angle of elevation, and that's when we're looking up at an object. The angle of elevation is formed from an observer's line of sight and a horizontal line. So if you look at the diagram here, if this little guy is looking up at this lighthouse, the angle formed from a line connecting him horizontally to the lighthouse, the angle formed there is the angle of elevation. And so we're going to use this guy in example 1. So, once again, I feel like a broken record, but draw and label your diagrams. So I went ahead and started my drawing because it took me a while and I'm not an artist. But Casey sights the top of an 85-foot tall lighthouse. So here's my lighthouse. I'm going to just label right now that this is 85 feet tall. 85 feet tall. 84 feet tall. Wow. Can't read. 84 feet tall. And he's looking at it at an angle of elevation of 59 degrees. So here's his eyes, and he's looking up at the top at a, what is it? Was 58 degree angle. All right. So now here's my triangle I formed. I overlapped the image just a little bit, which is fine. If Casey is 6 feet tall, how far is he standing from the base of the lighthouse? All right, so here's Casey, and he's 6 feet tall. All right, we're trying to find out how far he's standing from the base of the lighthouse. We have different pieces of information that we need in order to find this. I'm trying to get rid of that line. This distance, x, that he is from the lighthouse. Let's see here. Okay, so remember when we're trying to find the side of a right triangle, we have to know the angle, or an angle that's other than the 90 degree angle, and at least one side. Okay, well, I can't really find my hypotenuse. I don't have enough information given there for me to find that. However, because I know the height of the lighthouse and I know how tall Casey is, I can find this distance in here. And so I take 84 minus 6, and that's going to give me 78. So this side of my right triangle is 78 feet. Now, I can use these two pieces of information to find this side. Okay, this side is my opposite from my angle, and this side is adjacent. So that tells me I'm going to use TOA. I need tangent. So the tangent of my angle, 58 degrees, is equal to my opposite side, 78 over x. Now, all I do is solve my tangent function. So multiply both sides by x. So the x times the tangent of 58 equals 78. Then I have to divide both sides by the tangent of 58. That cancels those. And then leaving me with x equal to 48.7. So Casey is standing 48.7 feet from the lighthouse. So all you're doing here is you're taking something, your word problems, and you're using the keywords in the word problem and what it's giving you to form a right triangle and then solve for the missing piece of information. So remember, angle of elevation is when something is looking up at an object. So like on number 2, the kicker isn't looking, but the angle of elevation from the kicker's foot to the top of the goalpost bars is 17 degrees. And so you have to draw your picture and determine how you're going to use this information to draw your right triangle. I wanted to look at number 4. It's a little bit different. So here's my dog and my tree with the cat in it. I have a dog that's standing 5 feet from the base of a tree. So I'm going to draw that right there. He's standing 5 feet away from, actually, we're going to go from his line of sight. So he's standing 5 feet away from the base of a tree. He's looking up at a cat that's climbed 16 feet up the tree. So here's my cat. And the cat has managed to climb 16 feet up the tree. So we need to find the angle of elevation from the point the dog is standing on the ground to the cat. So I need to find this angle right here, the angle that he's looking up at the cat. Okay. Oops, I put 17. I don't know why I put that there. It needs to be x. So I got to look at what am I given? What am I given in retrospect to what I'm trying to find? So I'm given this side here and this side here, and I'm trying to find an angle. Okay, I got to look at what sides those are in reference to. Okay, 16 is my opposite side. 5 is my adjacent side. So once again, I'm going to use TOA. So I'm going to use a tangent function. So tangent of my angle x is going to be equal to my opposite side, 16, over 5, my adjacent side. Then all I do is use my inverse tangent functions, and I find whatever angle x is there. So I'll let you guys do that. Okay, if you flip it over on the back, we have what we call an angle of depression. And so when you're looking, this one's a little bit trickier. When you're looking down at an object, the angle of depression is formed by the observer's line of sight and a horizontal line again. So it is formed from this angle, or from this horizontal line to the angle of the line of sight. So it's this angle right here. Don't get confused, it's not this angle in here. This is a vertical line forming with the observer's line of sight. We don't want the vertical side. So the angle of depression is congruent to the angle of elevation because they're alternate interior angles. So notice when you create this horizontal line that forms your angle with the observer's line of sight, notice how that forms a line that's parallel to the horizontal distance from the observer to the object. Okay, that means my angle of depression and this angle here that would normally be my angle of elevation are congruent. So when you're given the angle of depression, you're essentially given the angle of elevation. So let's look at example 1. So we're going to use this lifeguard looking down at the swimmer. There's my lifeguard and my guy swimming in the pool. Okay, so he is, where's my paper here? Sitting on a platform looking down at the swimmer in the water. If the lifeguard's line of sight is 8 feet above the ground. So here's his line of sight. That's 8 feet above the ground. Okay. And the angle of depression to the swimmer is 18 degrees. So I'm going to draw my line of sight. Draw my line of... I hate this thing. Draw this way. The line of sight to the swimmer. The angle of depression. Sorry, that's what I was drawing. Lost my spot. Okay, so I drew my lifeguard's line of sight to the swimmer. That's this right here. This line right here. Okay. I need to draw a horizontal line from the observer to form, and that's what I did right here. I drew this line here. So that I can see where my angle of depression is, which is right in here. Okay. My angle of depression in this case is 18 degrees. So that means my angle of elevation from the swimmer to the lifeguard is also 18 degrees. So if I were to say the swimmer's looking up at the lifeguard, the angle of elevation, because the swimmer would be looking up, is the angle of elevation is 18 degrees. But since we're talking about the lifeguard looking down, we have to deal with the angle of depression, and it is 18 degrees. Okay? So, now, I want to find how far away the swimmer is from the lifeguard. So, I would say that that would be this distance here. So we're trying to find, in this case, the hypotenuse of my right triangle. And we're given this side here that the lifeguard is, the lifeguard's line of sight is 8 feet above the ground. And that's my opposite from my angle. So it's important to find, when you're drawing your drawings, to find the angle of depression and then draw in the congruent angle down here, because then that's going to help you when you form your right triangle. We don't have a right triangle up here that we're forming in order to find it using just this angle up here. So that's why it's important to know that these two angles are congruent, if that makes sense. All right. So now I'm using my opposite side from my 18 degrees here and my hypotenuse. So that tells me I'm going to use the SO function. So that means the sine of my angle, which is 18 degrees, is going to equal my opposite side, 8 feet, over my hypotenuse. I'm trying to find x. So again, multiply out my function here to solve for x. And then I divide both sides by 18. And that leaves x equal to 25.9. So the swimmer is 25.9 feet away from the lifeguard. So that's it. It's essentially doing the exact same thing as you were doing on the front, except for you're having to use that angle of depression to match it with the angle of elevation from the different observers. So I'll go ahead and have you do the rest of these. 2 and 3 on the front page, finish up 4, and then 6 through 8 on the back. When you're looking at number 6, what's the altitude of a helicopter? Altitude is how far something is in the air. So like when planes are flying, the altitude is usually I think it's 3,000 feet. And so that just means the plane is 3,000 feet from the ground. So you're trying to find out how far the helicopter is from the ground. That's what altitude means. On number 8, it's wanting you to find that keyword horizontal distance from Zach. So pay attention to what it's asking you to do there from the fountain that Zach is standing. Okay, so get these finished up. We'll go over these on Tuesday. Hope you enjoy your long weekend. And happy Easter.